So, what's up guys? Jerome Bayani is here from BSIT 2105, and for today's video is all about chapter 4, summarization in CCNA1. So, let's get started. So, on this receiving end, the physical layer receives signal across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. So, types of connection. The types of physical connection used in depended upon the setup of the network. For example, in many corporate offices, employees have desktop or laptop computers that are physically connected by a cable to share switch. This type of setup is a wired network. Data is transmitted through a physical cable. So network interface card or the NIC connect a device to the network. Ethernet NICs are used to a wired connection, whereas LAN or wireless local area network NICs are used for wireless, as end user device may include one or both types of NICs. A network printer, for example, may only have an Ethernet NIC and therefore must connect to the network using an Ethernet cable. Other devices such as tablets and smartphones might only contain a LAN NIC and must use a wireless connection. The physical layer The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. This layer accepts a complete frame from the data link layer and encodes it is a series of signals that are transmitted onto the local media. The process that data undergoes from a source node to a destination node is the user data is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the data link layer. The physical layer encodes the frame and creates the electrical, optical, or radio waves signal that represent the bits in each frame. These signals are then sent on the media. Physical layer media are There are three basic forms of network media. The physical layer produces the representation and groupings of bits for each type of media as copper cable, fiber optic cable, and wireless. Physical layer standards are protocols and operation of the upper OSI layer are performed in software designed by the software engineer and computer scientist. The physical layer consists of electronic circuitry, media, and connector developed by the engineers. Functions. The physical layer standard address three function area. Physical components. The physical components are the electronic hardware device, media, and other connection that transmit and carry the signal to represent the bits. Encoding. Line encoding is a method of converting a stream of data bits into a predefined code. Codes are groupings of bits used to encoding or line encoding is a method of converting a stream of data bits into a predefined code. Codes are groupings of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. Signaling. The physical layer must generate the electrical, optical, or wireless signal that represent the 1 and 0 on the media. The method of representing the bits is called the signaling method. The physical layer standard must define what type of signal represent a 1 and what type of signal represent a 0. This can be as simple as a change in travel of electrical signal or optic pulse. Bandwidth, different physical media support the transfer of bits at different rates. Data transfer is usually discussed in terms of bandwidth and throughput. Throughput Throughput is the measure of the transfer of bits across the media over a given period of time. Due to a number of factors, throughput usually does not match the specified bandwidth in physical layer implementation. Many factors influence throughput, including the amount of traffic, second, the type of traffic, third is the latency created by the number of network devices encountered between source and destination. Types of physical media. The physical layer produces the representation and groupings of bits as voltage. Um, as an example, standard for copper media are defined for the first one is type of copper cabling used. Second, bandwidth of the communication. Third is the type of connector used. And the fourth one is pin out and color codes of connection to the media. Characteristic of copper cabling. Network use copper media because it is expensive, easy to install, and how low resistant to electric current. Data is transmitted on copper cables as electrical pulses. A detector is the network interface of the destination device must receive a signal that can be usually decoded to match the signal sent. Copper media are having three main types of copper media used in networking. First one is unshielded twisted pair or UTP. Second one is the shielded twisted pair or the STP, and the third one is the COSA. Copper media safety. All types three of copper media are susceptible to fire and electrical hazard. Fire hazard exists because cable insulation and sheets may be flammable or produce toxin foams when heated or burned. Building authorities or organizations may stipulate related safety standards for cabling and hardware installation. Properties of UTP cabling. When used as a networking medium, unshielded twisted pair or UTP cabling consists of four pairs of color-coded copper wire that have been twisted together and then encased in a flexible plastic sheet. Its small size can be advan- advantageous during installation. UTP cabling standards are conformed to the standard established jointly by the TIA or EIA, specifically TIA or EIA 568 stipulates and commercial cabling standards for LAN installation, and it is the standard most commonly used in LAN cabling environments. Cabling. Some of the elements defined are cable types, cable lengths, connectors, cable termination, and methods of testing cable. UTP connection. UTP cable is usually terminated with an RJ45 connector. This connector is used for range of physical layer specifications, one of which in Ethernet. Types of UTP cable. There are Ethernet straight through, Ethernet crossover, and rollover. So Ethernet straight through, the most common types of network cable. It is commonly used to interconnect a host to a switch and a switch to a router. Ethernet crossover, a cable used to internet similar devices. And rollover is a Cisco proprietary cable used to connect a workstation to a router or switch console port. Properties of fiber optic cabling. Cabling. Um, what is that? Fiber optical fiber cable transmit data over longer distance and higher bandwidth than any other networking media. Optical fiber is a flexible but extremely thin, transparent, transparent strands of very pure glass that's much bigger than a human hair. Fiber media cable design. Optic fiber is composed of two kinds of glass, core and cladding, and the protective outer shield is called jacket. So, through the optic fiber is very thin and susceptible to sharp bends. The properties of the core and cladding makes it very strong. Types of fiber media, light pulses representing the transmitted data as bits on the media, are generated by either. These are laser and light emitting diodes, electronic semiconductor device called photodiodes detect the light pulse and convert them to voltage. Fiber optic connector. An optic fiber connector terminates the end of the optical fiber. A barrier of optical fiber connection are available. The main difference among the types of connectors are the dimensions and methods of coupling. Testing fiber cables, terminating and splicing fiber optic cabling requires special training and equipment. Three common types of fiber optic termination and splicing error are misalignment and gap and end finish. Properties of wireless media. Carrying electronic signals that represent the binary digits of data communication using radio or microwave frequency. So wireless does have some areas of concern including coverage area, interfaces, security, and shared medium. So the IEEE and telecommunication industry standard for wireless data communication cover both the data link and physical layers. Note that other wireless technologies such as cellular and satellite communication can also provide data network connectivity. However, these wireless technology are out of scope for this chapter. Wireless LAN, a common wireless data implemented in enable device to connect wirelessly via LAN. Wireless accept point or AP concentrate the wireless signal from user and connect to the existing copper-based network infrastructure such as internet. Wireless NIC adapter provides wireless communication capabilities to each network host. The data link layer the data link layer of the OSI model as is responsible for: 1 is allowing the copper layer to access the media, 2 is accepting layer 3 packets and packaging them into frames, 4 prepare network data for the physical network, number 4 is controlling how data is placed and received on the media, 5 is exchanging frames between nodes over a physical network media such as UTP or fiber optic. 6 is receiving and directing packets to the upper layer protocol, and the last one is performing error detection. Data link sublayers. The data link layer is divided into two sublayers. These are logical link control and the media access control. So, providing access to media, different media access method may be required during a single communication. Router interfaces encapsulate the packet into the appropriate frame, and a suitable media access control method is used to access each link. Controlling access to the media. So, media access control is the equivalent of traffic rules that regulate the entrance of motor vehicles on a roadway. The absence of any media access controls would be equivalent of vehicle ignoring all the traffic and entering the road without regard to the other vehicle. So, physical and logical topology. The topology of a network is arranged on relationship of the network device and the interconnection between them. LAN and WAN topology can be viewed in two ways. These are physical topology and logical topology. Common physical WAN topology. WANs are commonly interconnected using the following physical topology. These are point-to-point, hub and spoke, and mesh. So, hub and fold duplex. So, duplex communication refers to the direction of data transmitted between two devices. Hub duplex communication restricts the exchange of data to the direction at the time, while full duplex allows the sending and receive of data to happen stimulatively. Media access control methods. Some networks topology share a common medium with multiple nodes. These are called multi-access network. Ethernet, LAN, and WANs are examples of multiple access network. So some multi-access network requires rules to govern how devices there are physical media. There are two basic access control methods for sharing media. These are content-based access. So these are LANs, Ethernet LANs with hubs, and legacy Ethernet bus network are all examples of content-based access network. So the content-based access CSMA CA, another from one CMA that is used by E IEEE 802.11 LAN is carried sense multiple access collision avoidance uses a method similar to CSMA CD to direct if the media is clear. The frame, so these are the data link layer prepare packets for transport across the logical media by encapsulating it with a header and trailer to create frame. Frame types has three basic parts. These are header, data, and trailer. Frame fields, so framing breaks the stream into decipherable groupings with control information inserted in the header and trailer as valued in different fields. So generic frame field types include frame start and stop indicator flags, addressing, type, and control. LAN and WAN frames, so each protocols perform media access control from specified layer to logical topology. So that's all the summary of my chapter 4. I hope you like it. Thanks for watching. Bye.